Dear children, our last chapter was collection of data. In our last chapter, we had seen that what is the history of statistics. We also talked about what is population, what is sample. We also talked about the different methods of data, that is primary data, secondary data, and also how to collect those data. We talked about the methods by post. We also talked about the questionnaire method. We even discussed the advantages and disadvantages of all. Right? Now, in this chapter, we are going to see whatever the informations have been collected, how to present those informations, how to basically classify them, how to analyze them, how to present them, how to use those data into usable one. So let's get started with our second chapter, presentation of data. In our last chapter, children, we have seen what do we mean by data. Over here, we are going to see the two different types of data, that is quantitative data and qualitative data. Here, firstly, we will see the type of quantitative data, where quantitative data are of two types, that is having discrete variables and the other having continuous variable. Now, what do we mean by discrete variable and continuous variable? Firstly, we shall discuss the discrete variable. Say variable assuming definite or countable values within the specific range, then it is called discrete variable. I repeat, that is variable assuming definite or countable values within the specific range can be regarded as discrete variable. I would like to explain you this with the help of an example. Now suppose if we want to know that how many families having no child, how many families are having one child, how many families are there having two children, there are how many families having three children, and say how many families having four children. Now if you represent the whole data or collected information with the help of the table having two columns, that is the first column namely number of children and the second column namely number of families, you would find the number of children can be represented by the numbers 0, 1, 2, 3 and 4, and we can denote the number of families having the respective number of children. Right? This is the example of say discrete variable. Right? This is actually say a discrete variable into your quantitative type of data. Similarly, while we talk about say qualitative variable in say qualitative type of data, you would find that suppose if I take one example, if we want to say note how many accidents have taken place in different days, you would find the first column would be represented by the days of the week, that is from Monday to Sunday, and on the other side or the next column would represent the number of accidents, that is on Monday how many accidents had taken place, on Tuesday how many accidents had taken place. Okay, that is how we represent this data. Okay, this data can be regarded as say a qualitative type of data. Right? So these are few of the examples. Right? Similarly, if we want to define what is continuous data, we can say that data with continuous variable can be regarded as continuous data. I repeat, data with continuous variable can be regarded as continuous data. Now, what do we mean by ungrouped data, or what do we mean by raw data? Data obtained at the end of sample inquiry or population inquiry are called raw data or the ungrouped data. Children, we had seen earlier in the last chapter what do we mean by population inquiry and sample inquiry. Now, as it is the direct method to actually collect the information, you would find that whatever the informations that we collect from the field for the first time, whether it is population inquiry or sample inquiry, such kind of data are raw data. Why raw data? Because we just collect the information as we get, and that's why it is raw data or ungrouped data. It is never classified at the first time. The way we get the information, we just collect it, right? And that's why they are the raw data or the ungrouped data. Then children, what we do? We just collect this information and then we basically classify them as per certain features. Then such kind of data becomes your classified data, right? So over here, if we see to the definition of classified data, you would find it is a process of arranging all the raw data into proper form. When all the raw data are arranged in a proper form, can be called or can be regarded as classified data, right? Then it is also can be called classification of the data, and the data are the classified data. Again, a process of arranging of raw materials into proper form is called classification of the data, and the data so collected can be regarded as classified data. Now over here you would find, if we talk about the example given over here, you would find, say the demand of the commodity is there, right? That is 8, 10, 12 and 16, and say the number of days have been given to us, that is say 3, 1, 2 and 1. The total number of days is 7. Here you would find this is the example of classification of data. That is how the data are being classified. Now here we shall discuss the reasons to classify data. Why classification of data is necessary, or why the data are to be classified. The first one that you are going to find is what they given over here, that to represent the large data into simple, short and attractive manner. I repeat, see the first one, to represent the large data into simple, short and attractive manner. Children, you would find that once the data are classified as per certain features, you would find it becomes simple for the end users. Okay, the whole data are being represented in a short way, and obviously all the data are also say represented in a very attractive manner as per their features, right? So the first reason to classify data is that if the data is very large, you would find that it becomes very simple once they are being classified. Okay, the whole informations can be basically collected, and in a short way it could be represented, and obviously in an attractive manner also the large data could be represented once they are classified. So that is one of the reasons to classify the data. See the second one, what they given over here, for easy comparison between the various characteristics of the data. Now see, whatever the information, children, we collect from the field, you would find they always have different characteristics, right? So while we talk about say the reason to classify the data, you would find once the data have been classified in a proper manner or in a specific way, you would find that we can do the comparison, okay, between the features of two different kinds of data. The features or the characteristics of two different types of data could be compared, analysis could be done, and result could be found out, right? So that is also one of the features to classify the data. Now we'll see to the third one, what has been given over here, that to save the time, money and the labor. Say analysis based on say raw or ungrouped data requires more time, money and labor. Yes children, it is very much correct that if the data are classified, you would find that less time is required to analyze it. You would also find that less money is required, and you would also find that even less number of labors are required to actually analyze the data. So you would find even your time is saved. Even you would find that the money is also saved, and also say the energy of your labor potentials are also saved. So that is also one of the features or reasons that is why to classify the data. Okay, what is the advantage of classification of the data? That is the third reason. Now we will see to the fourth reason, that is to obtain the information easily regarding the various characteristics of the area under the study. Children, with the help of the classification, you would also find even we can understand and we can basically make out the features of the areas which are under study. Whatever the areas of the population we are doing the survey of, you would find even the features of those areas could be found out if we do the classification properly. So these are four reasons that is why we should classify a given data. Now, as we saw the reason to classify the data, why the data are to be classified, here we shall discuss now the types of classification. In the types of classification, we can see the quantitative classification and qualitative classification. If we talk about classification of quantitative type, see the example given over here, classification of number of children in 100 families. You would find the first row number of children, that is 0, 1, 2 and 3, and the second row is been given of number of families, that is how many children are having, families are having no children, how many families are having one child, how many families are having two children, and how many families are having three children. It is the same kind of example that we had taken previously. This is an example of quantitative type of classification, because if you will see to the first row, you would find the numbers are basically been given, right? That is 0, 1, 2 and 3 children, right? And that's why you would find such type of classification can be regarded as of quantitative type. See the second example over here, the table that has been given, that is tabulation of 100 families with reference to their core occupation. That is how the families are being divided in different kinds of occupation, right? The categories of occupations are, that is farming, business, service and labor. You would find in this example, that is there are 30 families who actually does farming, there are 25 families involved in business, 25 families are in service sector and 20 families are in labor. And you would find the total is 100. That shows that is how many families are being surveyed. You would find the first column, that is you can say here the row, that is it has been given about the core occupation of the family, and that's why such kind of classification is of qualitative type. So this is an example of, say, the qualitative classification, right? So we saw classification of two types, quantitative and qualitative, and their examples. Now over here we would see how the classification of quantitative data are categorized. The quantitative data are classified or categorized into discrete frequency distribution and you can say continuous frequency distribution. I repeat, that is the quantitative data are say categorized into discrete frequency distribution and say continuous frequency distribution. Now we shall study or see what do we mean by discrete frequency distribution and continuous frequency distribution. Children, here is the example of discrete frequency distribution, right? You would find over here that is, see the first column, number of accidents have been given to you, which is denoted by X, and the number of accidents is represented by the numbers 0, 1, 2, 3, 4 and 5. The second column you would find is of the telemarks. Now what do we mean by telemarks? That we will discuss when we will do the sums. But children, if you remember in your 10th standard statistics chapter in mathematics, you have already seen how the data could be classified and how the telemarks are to be put. But then too we will again discuss how to put up the telemarks as we will do the sum. Now the next column you would find is of the number of days. That shows the frequency, that is for how many times a particular event is being repeated. What does frequency denotes, or what does this frequency shows? That for how many times a particular event is being repeated. So if you see to this example, that you would find, seeing to the first column and the last column, that there were 9 days in the month that there were no such accidents, right? You would find there were 7 days, okay, in the month where you would find there happened one accident. There were 7 days into the month where 2 accidents took place, right? In 4 days you would find 3 accidents took place in a day, right? There were 2 days where 4 accidents took place, and there were 2 days where 5 accidents took place, right? So number of days have come up to 31. That is the whole month. That is in the whole month, okay, in for how many days, say for the number of accidents took place. So this is an example of discrete frequency distribution. Again I repeat, why discrete? Because you would find in the first column, say x variable is that which shows the numbers, right, in a discrete manner or in a discrete fashion, right, in a vertical form, right, and that's why such kind of frequency distribution or say classified distribution can be regarded as discrete frequency distribution. Here now we shall discuss the continuous frequency distribution. Now see children, what is the difference between the last example what we saw and this example? You would find in the last example, onto the x variable or onto the first column, you would find we had directly written the numbers, that is 0, 1, 2 and 3 number of children. Over here you would find that a certain range is there, that is 10 to 19, 20 to 29, 30 to 39, 40 to 49, and it goes up to 90 to 99. Okay, what are this? These are the classes. These are called the classes. We will discuss again while we will do the sums and all, but to just understand for a while what do we mean by continuous frequency distribution, you would find the whatever the things are been written onto this first column, you would find they are called the classes. When you represent the data into the classes, they can be regarded as continuous frequency distribution. Over here you would find this 10 to 19, 20 to 29, 90 to 99, they represent what? They are representing the number of roses. Again there are telemarks, right, and you would find the number of days, or you can say the frequency, right, that for how many days there were roses between 10 to 19, for how many days there were roses between 20 to 29, right? So that is actually the example of continuous frequency distribution. Okay, just to remember, why continuous frequency distribution? Because over here you are having the classes and you would find the frequencies are also been given to it, right? And that's why this is an example of the continuous frequency distribution, right? So over here we will stop our lecture today, right? And we will, in our next video, we will continue from here. So God bless you for time being. God bless you, and we'll see our remaining part in our next video. God bless you all.